Okay, so we have a new problem now. The bracket for the holder for the screen, it's in the way for the actuator. As you can see, it extends right on it. So when I place the motor there, it will hit on it. So I need some clearance there. So I'm gonna try to move this bracket on the inside of the profiles to the outside. Should be give enough clearance for that. Then I'm gonna have to hold this structure somehow while I'm doing these chains. I'm gonna use the jacks on two places. Hopefully it will hold the weight of the screen. Everything without I hope it will work. Let's try it, let's see. Okay, that works like I thought it will be. Now I'll have enough spacing there. It's mounted on the inside. In comparison to the outside there, so I'm gonna change on this one too. Alright, so now I'm gonna have to put this here for the actuator. I have something to grab on. So I'm gonna have to put those things on. So the ball bearing resistance, just slide them in, wiggle them, just there. Okay. Both sides. Now I have the locker screws. I have to go through here. Put some in here. Okay, finally got the correct screws there. I don't know why I ordered 35 before, but these are the ones you need for this. So it will be able to reach on the screws there. Okay, so I have this aligned. First of all, I had to make sure these are straight. Okay, so when I put these on, button. Okay. I'm not gonna tighten them yet. It's all the way there. So make sure this is vertically. Okay. Now come to the rest. Right. So this extension piece is really nice because now I can put actuator there. It's gonna be the same distance like the back part there. That it has this curve. So it's really useful for the Track Racer S models. And then I made sure to change this as well. So just gonna have to mount it. I already put some pieces in there for the mounting holes. For this. So yeah, let's go place some to see how it goes. Okay, so now I'm gonna put the actuator in place. You see how it sits, and there's enough space. Clearance on top, and then clearance there. So I'm gonna put the screws to mount this. Alright, so I'll make sure it's aligned before I try to put the holes in there. Alright, so should be I was gonna tighten them first, not before I do the top one too. Okay, now the same one here. Okay, so I have to make sure it's all aligned with the piece, and then I can tighten the screws. All right, now I'm gonna go ahead and try the same on the back one. The back one will have to do those T-nuts right on the frame. So it'll be interesting on the bottom because I can't really reach it. I'm gonna have to lift this even a little bit more, I think. That'll be interesting. I hope it doesn't tip over. It's already okay, let's see. Next is to put the back one. Now, if you place it, there's a little bit of gap. You probably have to adjust those to come closer, or lose them a little bit. Place it, push it from the top to match exactly. So the easiest way would be to use a mallet to see if it will fit there. I went too far. Oh, it fits now, but one side is loose, so still. Okay. Now the other one's loose. Alright. And now, I think it's perfect. There's very minimal motion there, so I can go on and tighten up the screws. I'm gonna have to move the T-nuts right under here and put them on. Alright, let's do that. So moving the T-nuts can be done using Allen key. Just move it under it until the holes are aligned. I'm gonna make sure it's there. Alright, I think that's good enough. Now I'm going to put the screws on. Oh, and I have to mention the caps that you use to capture the feet so they don't move, when, especially on your traction loss or surge platform. So before I get the model, it's too heavy to show you. You should see it there. So when it will keep it in there, no matter what angle. Okay, so before I drop them, I made sure to put the caps there. It's on temporary before I use it for traction loss. But this floor is really soft, so I don't want it to sink too much. So that will help for now. So let's see how I'm gonna release it. So this goes down in steps, so when you press it, so just do one at a time. So it will go down a little bit. Oh no. Lift that a bit here. Okay. Alright. So now, set the caps. Okay. That looks good. Now we need to do the other side. Okay, so as side note, I had to check to make sure the front actuators are not mounted too far in the back. It will be enough, so when I lift this, the back one's 150mm up, the full stroke, and these are all the way down. It will keep the front from touching. So right now, it's I don't think it's even touching. It has a few millimeters. So, which is good news because I wasn't planning to put the traction loss at source yet. So, at least I can use it as is without afraid of the front being hitting down. So I set this exactly to move up 150. What will be the distance when the actuators are powered up? You can see that's how it will look. Okay, like I said, we still need to do some wiring and cable arrangement, connect a few things before I can try it. Okay, so it's this time now that we have to wire up the servo drives. The servo drive will have some plugs that there's already red cables to plug here, but there's some that you have to screw on, and one of these is the power cable that we can use to feed 110 volts or 220 volts to servo drives. This has a plain 110 volt US plug, which if you see on the pinout, you can see which is the neutral, it's hot, and the ground, of course. So I already used the multimeter because sometimes the coloring might be wrong, but almost always the white one will be the neutral, the green one will be the ground, and the black one it will be the live wire that has the dangerous potential when you touch it. Remember, black is death, so don't touch this if you have it plugged in. So I'm just gonna plug wire it up. Let me zoom here so you can see where this is gonna go. There's a writing there. The first one is L1, and then L2, L3. All we need is the L1 and the L2. So L1 will be for the live. So just relieve a little bit the screw there, and then we'll do the L2 will be the neutral, and that's the same both for 110 or 220 volt. Okay, and then the ground, let me put it here, the ground will go to one of these screws here, the metal chassis. So I'm going to do the second one because the first one I want to use it for the power cable for the motor, which is gonna go on this horse here. So after zoom out here. So after that, it's ready to plug on our supply here. The 9 stripe, and then keep going. We'll do the next one and next one, and they all end up with the same ground, the same point. And then this can go on the wall outlet for 110 volts or to 20 volts. I think it supports. Yes, you can do. You have to make sure that these line strips can do 220 volts. This one is actually rated for 250 volt, so it will be okay to plug to a power converter. If you have one that you want to use the full power. The difference between 110 volt and 220 volt for the servos is with 220 volt they can reach the highest RPM speed without losing RPM rotation speed if it's loaded. Otherwise, you can, for this, at least for this system, there's not going to be too much load, so you can actually run it quite comfortably on 110 volts. So I'm gonna do the rest quickly and move on to the next to wire the cables for the motor. Alright, next we'll move to the power cable for the servo motor. The servo motor has two cables, one that goes to give the power and one that has the encoder. So this is the one for the power. You'll see it has 4 pins and then has 4 wires there. So on it there's some little letters. I don't know if you can see: Earth, W, U and V. So there's lettering on the servo drive, what connects what. The first one starts with U. Let me see if I can zoom it so you can see that. There's the U, the V and the W. So I'm gonna connect the first one, the U. You'll find that's the brown wire. Okay. That's there. Then goes the V. This is the V. That's the blue wire. And then the black wire, it's a W. Let's wire this here. Okay. And the E, earth, it goes to the ground. So we're gonna use the second screw, the aluminum chassis for this. Okay. So it's gonna go like this. Alright, and that is all the wiring you have to do on its servo drive. Essentially, the rest is just to plug the encoder cable for the motor and the data cable that goes to the MC controller, the sounds controller. I'm gonna wire the rest and we'll see how it looks. So I have here the cable for the encoder, which will plug here. So you have two cables that have to go to the motor. Okay, from each servo, two cables will go to the motor. That one will be with the 4 pins and the other one has multiple pins. That's the encoder cable and the power cable. It will move a little bit, but before I'll talk about the data cable. That's the DB25 pin cable, has all the wires in, and this is the one provided from Racing Lab. It's a nice metal connector, sealed it, and sealed it all the way through to the other end. So this will connect like here. top. You can put the screws on, but it's really I don't think it's required until everything is finalized. And then the other end, I'll connect it to one of the ports. Which one doesn't matter right now, I'm just going to do tests, so I'm going to plug all the 4 servo drives on the 4 ports, just to make sure I can move the actuators up and down for the first test, and then I can rearrange just these depending on the software I'm using, because SRS, for example, use specific order for the actuators, 1, 2, 3, 4, which has to be front left, front right, etc. Simhub, you can assign any port you want, and especially the vertical ones, and then you can just wiggle them while testing, so you can find which port is connected what. So yeah, let me plug a few more wires here, and we'll do some tests. So before I plug the cables to the actuators, I'm gonna quickly do a power up test. I plug some of the wires, the data cables, so I'm just gonna test to make sure that I can get power to these. Okay, you can see they have the alarm, which is normal because there's no feedback from the encoders yet. So I'm gonna take this off and we'll go pull some wires under the rig to reach. I'm gonna spread them in the middle right now, so I can do the test, and then I'll find a way to hide them with zip tie between and under the profile. So yeah, let's do this. Okay, so let's hook up some of the cabling. So these connectors are aerospace, you can say. Anyway, so I'm just gonna connect them here. You have to plug it and start rotating the clip. Make sure you don't unscrew, loosen up the ends. If it's loose here, for example, I can see it a little bit loose. Probably needs to be this bit tight. And then let's do the same for the other one. That's the multiple pin. So you have to rotate it until you hear it click together. So when it's aligned, then you can start rotating the little clip. And then you rotate it until it's nice and tight. Okay, so I got all the wiring done. I have plugged everything. I haven't plugged the belt tensioner yet, just want to see the vertical motion. So it's all wired. I put the cables away from the front because I want to test first to see how low it will go. Let's see. Now let's turn the power on. Alright. So all powered, and I can see on the controller it's all on park position. I'm gonna switch this here. We'll do some. Let's lift them up. Let's lift them. And I'm gonna do bits up and bits down. Oh, see? So if I do it, that's a little bit, it lifts the Okay. And put the camera on the tripod so I can see it better here. What's going on? All right. So let's see. Lift it up. Let's go down. Yeah, it goes a little over for a few, like 1 centimeter maybe. All right. I'm sure it will be fine in the software. Yeah, I'm gonna try set it up on simhub and try some basic stuff, because right now I think it's ready for the basic motion tests. Okay, so I connected the controller to the computer here, and I set up kind of simhub to test it. It's very easy to follow the instructions to connect to it. You just have to make sure to enable the motion icon here, so you can see all the controls, and then you just have to go to the motion part, output settings, and it will bring all the settings you need to set it up, so you can configure the geometry and control type, and from there it will tell you which platform you have. I have a 3D here with 4 corners, so ask you exactly how much millimeter is the distance between front and back, the distance between left right, and how long are the actuators, and then a few more things like to for center of rotation, if it's custom, if your seat is a little more on the back, so it's not on the center between the actuators. And this is useful more about the motion compensation, where you need to know exactly where the seat is, which has additional for that. Then it has some software spike filtering, how fast it will allow the actuators to move. It has really slow, so it will block fast movements, secure, or reactive to allow more motion, or very fast to allow the fastest motion. I just left it to reactive, it's good enough. With the actuator speed limit, how many millimeters per second. If thrust goes faster than that, it will block it. Axis limiting, how many degrees you wanna go, or roll, pitch, heave, and soft, that's the soft axis limiter. And then it has, if you have belt, you can calibrate the belt. I haven't connected it yet, so the connection here, you can see the connection, it's recognized the COM6 here. You can leave everything unaltered, except you have to go do the output assignation. I think that's a mistake there. Yeah, assignment. Anyway, yeah, I think it's friends. It needs to be, yeah. Okay, so you just go to the actuators output assignments, whatever, edit axis assignments. So I already found which is which, but I didn't want to follow all the wiring. Let's see where everything is going, so I just plug them with whatever order on the controller. Remove this. On the 1, 2, 3, 4, I didn't really care which connects where, and then I just had to go in here and do identify axis, which does a really cool thing. So it lifts the platform in the middle and just moves a little bit the actuator that you want to identify which one is moving. You can see now this one is moving there. Can you see it? There's a little bit of motion. The rest are not moving. Oh, you can see this one. Okay. So this is the front. This is the front right. Okay. So let's do the front left. Okay. Yeah. So you can see which one is moving. It does a little bit of motion, just enough so you can identify when you're sitting on the rig which is the axis you're using. And then you can click and select which one you're using. It even has the belt too option, so you can identify where is the belt. The rest, it's by default. Maybe you have to reverse direction if you have different type, fold back or something, but usually you just leave this all okay there. And you can see on the bottom also it should identify the correct firmware version for the controller. It's 226.7 right now, and the tape is type ST. So all you need to do now, after you can do enable motion, do the manual control up there, and then you can do some manual motion here. Do some roll. So let me show you here if I do roll all the way to the other side, and do some pitch. And the other one pitch here. Let's center it. So it's all basic commands here. Just drag the slider, it will move to wherever you want to go, and you can center it with the buttons on the side. And if you go to the extreme, to which corner, it will go to the corners without lifting legs. So let's do this. Let's go to the other corner. Other corner, and you'll see it does not lift any legs. Let me center it, and then you can just disable motion, so it will go down to the park position. But pretty much it. I'm gonna to click here OK, and then if you want you can save these settings so you have them. I think it's in the profile manager, and then you can import export settings or save. I think it doesn't let me save now. I already saved it before. Okay, so added an extra servo. It's a different color, but it's already set up for the belt tensioner I'm using. The belt tensioner is from Flagost. It's all 3D printed and belt driven with the motor right on it. And that's pretty much. It calibrates automatically with torque, like a normal actuator. So, and it pulls the motor in, or the belts. I'm gonna set it up here so we can see how it performs. So in case you're asking about the belt tensioner, that's the dedicated belt tensioner effects I have. It's for belt accessories, sway and heave, and I have them relatively little above the 50%. And here's the settings that I use for the belt. That's the default center, it's about 30. Maximum pull, I have it to a little over 50%, 59. The maximum release position, it's very low, about 2. At the parking, it's all the way down to 2 again. So that's the settings I use there. If you want to use similar for the flag ghost belt tensioner, there's some settings for the servo drive, which are already the same that were used for flag ghost provided for him to put in the servo drive, but you can also enter some extra parameters so to make it calibrate torque, because it's the settings he has are based on the putting a jumper on the XT connector on the controller, thrust controller. But I don't have any jumper. Right now you can see it's in the enclosure, it's untouched, so I'm using um, torque to calibrate. So the way it calibrates, it just releases all the way, and then it detects a little bit unwinding to the opposite direction, and then that's the start. And based on the calibration settings on the simhub, it always starts and has the same range for everything. That's a few words I need to say about this. I'll probably post some of these settings so you have an idea. Similar belts can work like that, but could be just with a few adjustments to work fine.
Abandoned car stories, and I know it's the internet, but one of these is too good not to go check out.
So here's a quick walk around the sim. I haven't secured anything yet. The servo drives are still on the floor. After doing some testing, make sure everything's fine. I had to tighten up the column for the steering wheel, the screen, because it came loose after using the Forza Horizon. So I'll have to also arrange the cable and put this in a nice enclosure. Racing Lab might have something to provide for that. I'll see if I can add it on this video or next video when I get this in my hands. So as you can see, it's very easy. The wires are all over the place. I have to arrange them. Just mount them on the rig. Optional belt tensioner, Flagost. Look him up on my Discord. Belt tensioner. The remote for the power on the belt, so you can turn it off if you need to. What else? It's very easy. These are high modular, these rigs, so you can adjust everything. The position of the seat, the pedals, the screens, steering wheel, everything is adjustable to fit your needs. I haven't exactly put everything the way I like yet, but I just wanted to try the motion. So now I know a few things I need to adjust, like the seat position of the pedals, plus steering wheel go a little higher. I think it's a little bit low there. But yeah. It's very easy to get into motion simulation these days. The support for motion is amazing, especially simhub. It has the best support for motion from what I've seen. It's almost like a plug and play. You follow all the steps on the setup, and you can find where is everything connected and have motion in very short period of time, you know? Yeah. Oh, and my screen. That was a little bit pain to mount. I had to put extra clamps because this is not enough. With all the motion I have, it will fallen off. Yeah, so I just had some extra support there on the bottom, some bars. But yeah, everything is modular. You can fix things easy on this thing. And another thing, while testing this platform with the Racing Lab actuators and the simhub and everything, I get the same pains when I accelerate really fast with my 400 horsepower car. So yeah, so you do feel the accelerations because of the way it tilts at everything. Plus, you get extra accelerations. For example, if you do jumps, that it will just jump over, then down again. Yeah. So yeah, that's lots of good things there. Of course, on real racing, I have to tune this down. On Forza Horizons, that it's purely arcade game. It really almost killed me. I couldn't do more than 15 minutes on that. I had to go and tune everything down. Otherwise, it's extremely fun. If you have a relative want to impress him with it, just put Forza Horizon on. I don't know, 50% the settings, intensity and everything. Yeah, that will be the best thing. Okay, so that's I don't know. It's just so exciting to have a motion platform that actually works. It gives the perfect feeling for what you need to do. All right. So thanks for watching this video. I'm pretty much done with the setup. I just need to set up some games, some extra games, and do some driving around. But otherwise, soon I hope to be adding traction loss at surge. I already have the parts here, except the aluminum profiles, which I'm going to have to use to build upon to connect all the other little pieces I have. So I hope to be posting some videos using it with different games to see, and even comparison with other software. Hopefully we'll see how it goes. Okay, thanks for watching.